Hello, my name is Jon Howard. I work in the Life Support Learning Center here at UVA. In addition to my life as a nurse, previously I was a high school mathematics teacher, and so today I get to talk about medication math with you in this video. What are our objectives for today? We're going to focus on medication math, unsurprisingly. We're going to spend a little bit of time about setting up how to multiply fractions, be a little bit of a review of your high school career, hopefully there. And then how to set up any mid-math questions and multiplication of fractions. So why do I need to do this? We need to be able to do mid-math so we can give the right medication and the right amount by the right route and all the rest of the rights as well. But really what we're focusing here is getting the right volume, doing the right things with the mathematics. We want to be able to recognize too much, too little errors. We want to be able to double check someone's or some things math. I love Epic. However, I'm going to double check its math as well. And generally, doing all that gives you more confidence in your medication administration. So let's talk about multiplying fractions. Basically, the way we're going to have these things set up, everything's a multiplication or a division, and so it's straightforward. Multiply the tops, multiply the bottoms, do your final division at the end, and you're done. Right? The tops are the numerators and the bottoms are the denominators. I'm not going to use the fancy words. I'm just going to call them tops and bottoms. Right? Once I get this set up, I'm going to use a calculator to do the arithmetic. The thing that's going to be important with these is setting up the problem in the first place. And once you do that, everything else is going to be a piece of cake. Use a calculator to do it. But in this case, I've got 3/5 times 2/3 times 5/8. That's the same thing as 3 times 2 times 5 on the top. And 5 times 3 times 8 on the bottom. Comes out to be 30 over 120, a final result of 0.25 or 1/4. I'm going to talk about canceling for a second as well. If I've got the same number on the top and the bottom, well, same number top and bottom, it's something divided by itself. That's always 1. And that means I've got 1 times the rest of my mathematics, the rest of the fraction multiplication. Anything times 1 is itself. It basically goes away. I can cancel them off. So in that previous example, we had 3/5 times 2/3 times 5/8. That's 3 times 2 times 5 over 5 times 3 times 8. Hey, I've got a 3 in the top and the bottom. That's 3 over 3. That's 1. I can cancel them. They go away. They don't make any. They make the problem equivalent. 3 times 2 times 5 over 5 times 3 times 8 is equivalent to 2 times 5 over 5 times 8. Oh, look, I've got 5 on the top and bottom. I can cancel those off. I'm left with 2/8. I'm going to rewrite that as 2 times 1 over 2 times 4. Why can I write 2 as 2 times 1? Because anything times 1 is itself. I haven't changed the value of that number. 8 is the same as 2 times 4. I can write that way as well. Hey, I've got 2 on the top and the bottom. I can cancel them off. And there I am. I'm left with 1/4 or 0.25. The same answer as I got the other way. Which makes sense. Same question, I should end up with the same answer. What we did with the numbers, we can do with the units as well. I'm going to give a little bit of a complicated problem going here. A little bit, it's not that complicated. But we're going to focus a little bit more on the units with this. So I'm not using a mid-math problem for this yet. What I'm going to give you instead is I've got a yard that's about 100 feet by 200 feet. It's like a rectangle. And I'm going to do something to it. I'm going to put down some fertilizer. I'm going to do whatever, reseed it, whatever you can think of. And that's going to cost me $1 for every 2 square feet that I'm having treated. So here's my original problem. I've got a yard that's 100 feet by 200 feet. To find its area, I do the 100 times 200. And that's going to cost me $1 for every 2 square feet. So there we go. That's the left side of that line. The right side of that line, I've got a very small rewrite. The only thing I'm doing is making everything explicitly fractions. 100 feet is the same as 100 feet divided by 1, because anything divided by 1 is itself. So I've got 100 feet over 1 times 200 feet over 1 times $1 over 2 square feet. What's that going to look like? Next line down here, I can just multiply across. 100 feet times 200 feet times $1 over 1 times 2 square feet. I'm going to take that and rearrange it a little bit. I'm going to put all the numbers in the front and all the units in the back. Since it's all multiplications, I can move them back and forth like that. If you want to dig up commutative property from mathematics, you can look that up. So I've got 100 times 200 times 1, feet times dollars, all over 1 times 2 square feet. Feet, dollars. That's a weird unit. Yep. And that's fine. It will clear itself out by the time we're done. Here we go for the next line down. I'm going to take a calculator. 100 times 200 times 1 is 20,000. Feet, dollars. The feet is really starting to bug me. Anything times itself is that thing squared. So feet times feet is the same as feet squared. On the top, I've got 20,000 feet squared dollars. Over on the bottom, 2 square feet. I can cancel. But hey, feet squared, is that the same thing as squared feet? Yes, it is. It's the same thing. It's feet squared is the same thing as square feet is the same thing as feet. My name is Jon Howard, but my phone name is Jonathan Howard. 2 different names, but I'm still the same person. It's the same with this. I've got feet squared on the top, and I've got feet squared essentially on the bottom. I just called it something else there. They can cancel. They are exactly the same thing, and they can cancel. If I had feet squared over feet, slightly different problem, but I've got feet squared over square feet. Those are exactly the same thing. Cancels off. I've got 20,000 divided by 2. That's 10,000. The only unit left is dollars. And that's the unit I wanted. How much was this going to cost me? So I can cancel units like I cancel numbers. Now, I used that thing about how much it was going to cost me. I called it was going to be $1 for every 2 square feet. Right? So that's the same as a half a dollar per square foot. If it costs me half a dollar per square foot, that means I can get 2 square feet for every dollar. Those are the same thing, essentially. This fraction is equal to 1 because it's the same thing on the top and the bottom. A half a dollar equals 1 square foot in this case. That's how much it costs me to treat a square foot. 2 square feet is the same as $1 because that's how many square feet I can get for $1. It doesn't matter which way I use that fraction, top or bottom, in this case because it's the same thing. It's talking about the same thing on the top and the bottom. So now I'm going to do the similar problem based off that stuff we were using last time, except this time I've got a certain amount of money and I want to know how many square feet I can treat with that. So I got $5,000, wish I did, but I got $5,000 and I'm going to use the fraction, the next fraction is the 2 square feet per dollar. It looks like it's flipped from last time. That's because it is, but it's still equal to 1. It's still the same thing. So I got $5,000 over times 2 square feet over 1 times $1. Move all the numbers out to the front, move all the units to the back. I've got $10,000 square feet over $1. Hey, I got dollars on the top and the bottom. It's exactly the same unit. I can cancel them. So now I've got 10,000. 10,000 divided by 1 is 10,000. And the only unit left is square feet. That's good. That's the unit I wanted. How big of an area can I treat for this amount of money? So now let's start using this in medications. To my mind, there's basically 3 steps to this. What units do I have right now? What units do I want to have at the end? And how do I get from here to there? And you saw that a little bit in the previous problem, right? I started with dollars. I wanted to end up with square feet. I want to do something in there with some fractions to get me the units to work out correctly. A little sidebar, remember, in med math, all meds, everything is in metric. Everything is in metric. All units should be metric. We are not doing weights and pounds. All weights should be in kilos. Everything else should be in kilos. The volume should be in milliliters or liters or something liters. Right? We're not doing teaspoons or anything else weird these days. Everything's in metric. So here's my first example. I've got an order for vancomycin, 15 milligrams per kilogram. The vancomycin is going to come in 1,500 milligrams in a 500 milliliter bag. The patient weighs 74 kilos. So what do I have right now? Where am I starting from? I have an order right now for vancomycin, 15 milligrams per kilogram. And to make it really obvious, I'm using the fraction. I can rewrite that as 15 milligrams over 1 kilogram. What I want to have at the end, what units do I want? I want milliliters. How much volume am I actually going to give to this patient? I want to end up in milliliters. I don't know how many milliliters yet, but that's the unit I want to end up with. All right. So how do I get from here to there? And the way I'm going to do that is I'm going to use those other pieces of information and use them as fractions and make the units work out correctly. This is the way I've set this up. There's the 15 milligrams and 1 kilogram. That's my start. And my answer I want to be in milliliters. Did I do the units correctly so that the only thing I have left is milliliters? Let's go see. 15 milligrams. Hey, I got milligrams and milligrams, top and bottom. I'll flip the 15 and the 1500. So the milligrams over milligrams cancel out. I've got kilograms, top and bottom, 74 and 1. So the kilograms over kilograms cancels out. So the only unit I have left that's not been canceled is the milliliters. All right. The rest of this is arithmetic. Go grab a calculator. So I'm going to put all the numbers in the front and all the units in the back. 15 times 500 times 74 milliliters is the only unit left. 1 times 1500 times 1. I'm certainly not doing 15 times 500 times 74 in my head. So it comes out with the calculator 555,000 over 1500. Do the division. 370 milliliters is the end. And we're done. Again, the biggest part about this isn't actually doing the arithmetic. It's setting up the problem with the fractions so that when you're done, all you got to do is run it through a calculator. Second example now. Let's do another example. So during a post-arrest care, you have an order for norepinephrine 0.3 micrograms per kilogram per minute for a patient weighing 97.6 kilos, and your norepi bag from your code pharmacist is coming to you at 4 milligrams per 1,000 milliliters. So how do I write that norepi 0.3 micrograms per kilogram per minute? Anytime you're saying per, you're dividing. So I'm going to set this up as one fraction is 0.3 micrograms per kilogram minute. Right? Anything that came after the word per is in the denominator, in the bottom. So now, what do I have right now? Here, where's my starting point? Right now I have that order, 0.3 micrograms per kilogram minute. Where do I want to be at the end? I want my drip rate. I want milliliters per minute. I don't know how much that is yet, but that's what I'm looking for. Okay. Now I just need to use the information I have, put it as fractions, and make the units work out correctly. So how do I get from here to there? Here's my setup. I've got this. Now, that second fraction there didn't show up anywhere in the previous work on the previous slides. That's okay. It's a conversion factor. 1 milligram is exactly the same as 1,000 micrograms. So basically, the top and the bottom of that fraction are the same thing. 1 milligram is 1,000 micrograms. That means it's 1. I can multiply anything by 1. It doesn't change the answer. So any conversion factor you need, you can just put in there. It's equivalent to multiplying by 1. I've got the norepi concentration. Usually that concentration is written as 4 milligrams per 1,000 milliliters, but that's not the way it's going to work for me to make the units work out. I'm going to use it as 1,000 milliliters has 4 micrograms in it. It's still the same thing. And then I've got the patient's weight in there as well. Let's go see if we got the units to work out correctly. There's on the left-hand side, that second line, there's the big problem with everything written out. I'm going to take all the numbers to the left and all the units to the right. That's a mess of units over there on the right-hand side. That's okay. We're going to cancel a bunch of them. Next line down on the slide, there's the numbers, and we're going to start canceling units. Do I have micrograms top and bottom? Yes, I do. Cancel them out. Do I have milligrams top and bottom? Yes, I do. They get canceled as well. Do I have milliliters top and bottom? No, I don't. The milliliters stays around. Do I have kilograms top and bottom? Yes, I do. Those cancel out as well. And then on the bottom, I also have a minute that has not been canceled. So my final unit is going to be milliliters per minute, which is the unit I want. Okay, and at that point, the rest of this is arithmetic. 0.3 times 1 times 1,000 times 97.6 gives you 29,280. 1 times 1,000 times 4 times 1 gives you 4,000. The division gives you 7.32 milliliters per minute. And that's the answer. That's the units you wanted, and that's how fast this guy's norepi drip is going to go. All right, more examples. We're going to start getting you involved in these. We've got an order for methylprednisolone, 1 milligram per kilogram for a 36 kilo child. Methylprednisolone comes as 125 milligrams and 2 milliliters. I'm actually going to ask you to pause the video here, take a few moments, work this problem out, see what you get. Right? Where are you starting from? What do you know right at the start? What units do you want to be at the end? And what are you going to do to get from here to there? So take a few seconds for right now, work the problem yourself, and then unpause me, come back, and we'll see what we get. All right, let's see what we got. Right now, I'm starting with 1 milligram per kilogram. That's the order I was given. I want it to be in milliliters at the end. So I need to make my units work to get from milligrams per kilogram to milliliters. I've got 1 milligram per kilogram. I've got the concentration. Usually written as 125 milligrams per 2 milliliters, but in this case, it's going to be 2 milliliters and 125 milligrams. Patient's weight's 36 kilos. What happens with the units? Do they cancel? I've got a milligram on the top and bottom. It goes away. I've got kilos on the top and bottom. They go away. The only unit I have left is milliliters. That's what I want. Cool. Now it's arithmetic. 1 times 2 times 36 over 1 times 125 times 1. 72 over 125 gives me 0.576 milliliters. And I'm done. Next example, we're going to have you do this again, partly on your own. Order for diphenhydramine 50 milligram liquid suspension for a child. It comes as 12.5 milligrams and 5 milliliters in this form. Pause me for a second. Look at where am I starting from? What units do I want to end up with? How do I get from here to there? Take a few seconds to do that now. When you're done, unpause me and we'll see what we get. Here we go. I'm starting with 50 milligrams. I want to end up with milliliters. Okay, so I can set it up like this. 50 milligrams times 5 milliliters over 12.5 milligrams. I've got milligrams over milligrams. They will cancel. The only unit I have left is milliliters. And now it's just arithmetic. 50 times 5 over 1 times 12.5. 250 divided by 12.5 gives me 20 milliliters. Some of you may be saying, you know, I could have done that by myself without this. I get it. The benefit is it's a nice way to double check and make sure. Also, the more you get used to doing it this way, the easier it is for the harder ones as well. One more example. Example number 5. Order for naloprilat 0.625 milligrams. It comes as 1.25 milligrams per milliliter. Take a few seconds here. Where am I starting from? Where do I want to end up? How am I going to get between the two of them? Take a few seconds and we'll see what you get. So here we go. 0.625 milligrams is my start. I want to end up with milliliters. How am I going to get from here to there? There's my setup. 0.625 milligrams times the concentration. 1 milliliter is 1.25 milligrams. Milligrams top and bottom cancel. The only unit I have left is milliliters. Do the arithmetic. 0.625 times 1 on the top, 1 times 1.25 on the bottom. I do the division and I get 0.5 milliliters. I'm going to take that example and extend it for a second. You can double check yourself as well with these things. Right? The ordered dose was 0.625. The concentration is 1.25 milligrams per each milliliter. So the ordered dose is less than the amount per milliliter. I should be ending up with something less than 1 milliliter. If I ended up with something more than that, need to do some math, to math checking with this. This kind of quick double check helps you avoid 10 times off errors. We've misplaced a decimal point or we type something wrong into the calculator and it's just off. So this is a quick once over. I should end up with something less than 1 here. I did. Okay, then it's probably reasonable. There's another really, really quick double check that works for most medications, and that's if you're pulling more than 2 vials of it, you need to check some math. It's either yours or the ordering provider's. I don't care whose it is, as long as it gets caught. Most medications do not need more than 2 vials pulled to fulfill the order. There are a few. The initial dose of dantrolene for me, if I have malignant hyperthermia, involves 9 vials. Okay, every once in a while you get something weird. But in a lot of cases, if you're pulling more than 2 vials to fill something, double check everybody's math. Right. If you have any questions, put them in the comment section below. We do monitor our comment sections. We will see what we can do to help you with this. But I hope this video was helpful for you. Thank you very much for joining us today. We hope to see you again soon in one of our other videos, or in one of our classes, or in one of our simulations. Have a good day.